Surface area of a triangular prism, one step further than the surface area of a rectangular prism. So when we do the surface area of a triangular prism, we want to try and list out the same thing we did with our rectangular prism, all the sides that we have, and we can label them. So here we have a top piece, that's this top piece here, okay? We label that the top. The left side over here, that you can't really touch, but you can kind of see it's this right here. The left side, we've got the bottom, right? And we also have the front and back, and the front and back are triangles, so that's where progression to a triangular surface area becomes a little bit more difficult. We've listed all of the sides that we want to collect the data on so that we can add all that up and get a total surface area, the same as we did for a rectangular prism. Okay, so at this point you can pause the video, you can fill in all of these, and you can see if you can find the total surface area of the triangular prism. Once you unpause the video, if we start to carry on to complete this, we're going to have to use the Pythagorean theorem. And you might be thinking to yourself, why would we need the Pythagorean theorem? Well, this edge right here, we don't know the length of that edge because it wasn't given to us, but we can figure it out because what we have right here is a right angle triangle, and we have a right angle triangle that has A and B given to us, and we just have to find C. So in order to find the length of this unknown side, so we can calculate the total surface area of the top, you know, the length times the width, we're going to have to use Pythagorean theorem to figure out that unknown side. So we would start by saying, you know, 8 squared times 7 squared is C squared. These came from, this is A and B. There's our A and B right here, A and B. So A squared plus B squared equals C squared, okay? We can also go 8 squared is 64 because 8 times 8 is 64. 7 times 7 is 49, and we still have C squared here. When we add these together, we get 113 equals C squared. To get down to our C, to go from C squared to C, we have to find the square root. When we find the square root of C squared, it's C. Whatever you do to one side, you have to do to the other. This is called balancing your equation. So essentially we have to find the square root of 113 to get to 10.63, but now we can label this as 10.63 for this unknown side right here. Then we can go back and start collecting all of our data like you can see. So the bottom is 8 by 5, which is 40. The left side is 7 by 5, which is 35. The top is 10.63 by 5. 10.63 times 5 is 53.15. And this is where it gets a little bit interesting. The front and back, what shape, this red outline here, what shape is the front and what shape would the back be then? They are two identical triangles. And they're two identical triangles that end up making a rectangle because if they're 8 by 7s, 8 by 7 triangles. And when you stack the front one on top of the back one, you get an 8 by 7 rectangle. So if you're going to do two of them, the front and the back, all you have to do is the length times the width, because when you stack them, it makes a rectangle. 8 times 7 is 56. You could also use this formula, area equals base times height divided by 2, so we could go base times height divided by 2, but then we're going to end up multiplying that by 2 because there's two of them, there's a front and back. So when we times by 2, we cancel out, and what we're left with is the base times the height, the base times the height. So we can skip a whole step there and just go base times height if we have two identical triangles. We add all this up, we get a total surface area for the triangle.